Wow, what's going on here? You've got some more expansions popping up, and I've got a question for you, as usual, right in the middle here. Which are old and which are new types of expansion? Can you look around the screen and see which sort you've seen before and which ones are different? Because this is further expansions. So let's start over here. Yes, we did some of those back in an earlier presentation, way back in the review of algebra. And this one was a special expansion. Do you remember its name? It's a difference of two squares. What about this one? Oh, that's a square, isn't it? X plus 5 squared means x plus 5 times x plus 5. And that we called, do you remember what we called that one? And could you do it in your head without a piece of paper and pen? It's a perfect square, isn't it? Oh, I think this looks new. What do you do with 3 brackets? Or with an x and 2 brackets? Or with 2 brackets but one's got 3 terms in it? Well, that's what we're going to investigate. Gee, this algebra language is really building up, isn't it? You know, we thought we were smart introducing letters to stand for missing numbers and stuff and to describe patterns. But gee, we've created quite a big area here where we've got to look at our language, our symbols, and how we combine them. And that's what algebra is about right at the moment. Okay, well, come on down and let's see what we can do with these. And here's the first one. And the screen clippings here are from Hayes and Harris, a national curriculum in Australia, Year 9 textbook. So you should get that and have a look at it. Okay, so here's the first one that we're going to do. We've got 3 terms in here and 2 in here. What does it mean? Well, first of all, before we try to do it, let's see what it means. It means we've bundled up 2x lots of this and 3 lots of this. That's what that means. We have a bundle here of 2x plus 3 lots of the second bracket. That's what we're meaning there when we write that notation. So now we're going to expand it into all the things that means. So we have come down here, 2x lots of each of everything in the second bracket. Then we've got 3 lots of each thing in the second bracket. Okay, so that's the idea. It's all bundled up as 2x plus 3 lots of, there's no times in the middle here, but we leave the multiplication sign out, don't we, between brackets in algebra, and we understand that's what it means, lots of. So we've got to do all these multiplications here. Let's do them. 2x by x squared will be 2x by x squared, x cubed goes to the next power. 2x by 4x will be 8x squared. Then 2x by 5 will be 10x. Then we go through in 3 land. 3x squared and 3 times 4x is 12x, 3 times 5 is 15. Do you get it? It's the same system as before, only enlarged or expanded further. Okay, let's now collect up like terms. There's only this one term in x cubed, but x squareds we've got this one and this one. See how the book's placed terms under each other? So the x squareds under each other give 11x squared, and 10x and 12x is 22x, and then the 15 by itself. So here's that little rule. All terms of the second bracket multiplied by all terms in the first one by 2x and then by 3, and then we collect like terms. Do you get it? And here's a little person telling you what we've just done. So that's important to learn the rule, but just remember what you're doing and what that rule is saying about the meaning of the expression. All right, you want to do some, come down, and here's some from the textbook here. 5E, question 1. I think you should do most of those and just check you're on the right track. So as you do one, forward the video here and have a look at the answer, because I've got them down below. Then go back and do the next one. Don't do a whole lot and find you're getting them wrong, because you're practicing the wrong thing that way. Come down, let's look at the answers now. So there are your set of answers. So check it all out, go backwards and forwards until you feel confident. Let's go on to the next type. There's only a few types here, fairly short presentation this one. So here, x plus 2 cubed. Ooh, what might that mean? Well, we've done powers or indices before, So what does a cube mean? It means the thing is multiplied by itself 3 times. So I'll put that up here. That's what that really means. But we're not going to treat it that way for our expansions. You can. We'll do one of those later. But you could say it's x plus 2 by x plus 2 squared. And why might you do that? Well, because a perfect square you're supposed to know off by heart now. Let's look at that. It's the first term squared twice the product plus the second term squared. Okay, so do you know that? You might have to go back to special expansions and make sure you can do that in your head or mentally or orally. Okay, let's look at what it means now. It's x times each of these. So it's x cubed, there it is. X by 4x is 4x squared. X by 4 is 4x. Putting the matching or like terms under each other, 2 by x squared is 2x squared. 2 by 4x, 8x. 2 by 4 is 8. Now there is only one x cubed term, so that stays by itself. There is a 4x squared and a 2x squared comes to 6x squared. 4x plus 8x comes to 12x, and you've got 8. Same steps as before. So try and keep your understanding the same for each one. It's the same idea, the same meaning of the notation, only they look a little bit different each one. All right, are you ready to have a go at that? Come down now and have a look. So we'll do each of these the same way. Break them down into an ordinary term times a square, and then use your understanding of a perfect square to write it straight down. Okay, can you see the idea? Let's have a look at the answers to those. Here they are. So check your work as you go. Don't practice the wrong thing. As you do one, forward the presentation, have a look, or have a look at the answers in the book, either way. All right, let's keep going. We've got some little variations here for you. So here's another one. This one is a threeer. We've got 3 things times. And probably the easiest way here, and we've got another one over here, we'll come to that in a minute. I think the easiest way here is to take 2 at a time. Let's do this, because that goes way back to our revision of expansion of brackets. So it's x by x is x squared. X by 1 is x. So now we're down to a 2er, just 2 brackets multiplied together. So taking it in parts, understanding that what we're talking about here or doing is multiplying everything out. Okay, so then we've got this by this, x cubed. This by this, back to our basic idea, 2x squared. Then x by x, x squared. Then x by 2, 2x. So just remember, there's a Huddyism now. Maths learning is sequential and cumulative. That means that as you go through and do things in sequence, you have to accumulate that knowledge. Don't forget what we did before with 2 brackets, and keep that knowledge and keep practicing that. Okay, so we've got 1x cubed term, got 2x squared plus 1x squared. 2 dogs plus 1 dog is 3 dogs. And then 2x on the end, collecting like terms. Let's have a look at this one. What will we do? We'll probably group these 2 and do those 2 first, because everything has to be times by everything else. But look at that. That's a difference of 2 squares. X take 2, x plus 2. Same first term, same second term with opposite signs. Remember that pattern. So you should know that straight off by heart. X squared take 4. Then it's this one by this is x cubed. This one by this, neg 4x. This one by this, x squared. This one by this, neg 4. Okay, so we've got 1x cubed term, we've got 1x squared term, 1x term. So there's no collecting of like terms here. All the terms were different from each other. Your turn. Let's have a look. This little dude here is saying, always look for ways to make your expression simpler, so that we're pulling out the difference of 2 squares in part B, because we spotted it sitting there. Okay, you can do it in several different ways as long as everything's multiplied by everything else. But here's question 3. Pick out your specials there if you can find any, and otherwise it's everything multiplied by itself. multiplied by the other things. So everything in the bracket multiplied by all the other things in all the other brackets. So you've got to do them in a sequence. Okay, let's have a look at the answers. There we have them. So check your work. Lots of practice needed here, so you're really confident. Remember, it's just a notation, a language in maths. Now that we've got this pronumeral coming in for algebra to solve problems and describe patterns, we've got to be able to work with it in all sorts of different situations. So let's go down now and have a look at this one. So this has got some more patterns in it probably. So you're looking at 3 different ones now. Start with 2, get them done, and then multiply by the third. So generally you will take those 2 and then afterwards multiply by each of those. Okay, and if you can see any patterns, then you might do those first. Difference of 2 squares. I don't think there are too many patterns in that one. All right, let's have a look at the answers. There we have them. Okay, and do you want a challenge? This is in the Hayes and Hayes textbook with red around it, so it means that they are more challenging. Or look at this big one. You've got to multiply everything by x right the way through, and then by -1. And if you're really up for a challenge, have a go at that one. Okay, pause presentation, have a go, and I'll show you the answer in a minute now. Okay, here we go. There are our answers. How'd you go with the red ones? They are really quite hard. So have a look, see what you think. And I'm going to finish there for expansions now. That's all we have to do for year 9. So the idea now is that you try to practice, and I'll catch you in the next presentation, which is about algebraic fractions. Cheers for now.